Hello and welcome to this demo video of 8Cage. 8Cage is a joint project between Ingenieuren and the TUM. In this video I want to show you all steps of 8Cage, and we're going to start by showing you the configuration wizard that is used by developers and testers to configure 8Cage for automatic detection. In the first step we need to select a Matlab Simulink model, which is going to be the large example in this case. And we're going to need to select a subsystem, where we're going to select the root subsystem here. 8Cage is then going to tell us which parameters are not defined in the root subsystem, and we're going to choose a file in which these parameters are defined. In the next step, we're going to select fault models to test for. For this demo, we select the fixed point division overflow, the absolute value overflow, and a customer-defined threshold fault model of TMP out. In this step, we could specify the ranges, but for demonstration purposes, we're going to leave this out. For our symbolic execution later, we need to know how many steps the model should be simulated, and that's going to be entered here, as well as if our test case generation should be automatic. In the last step, we specify the contact data, and once we hit finish, an automatic testing process is started. The automatic detection process is going to start by using a model analysis, then go over to test data generation, and then test case execution. In our scenario, we want to find an absolute value overflow that's caused by this block. The first step is the model analysis, which is run in Matlab, and we're going to tell Matlab to find any absolute value block that has an integer input. Among the set of found blocks is our block that's going to cause the failure. In the second step, we're going to generate code from this Matlab model automatically in order for CLI, our symbolic execution engine, to run on this code and find inputs in order to cause this failure. CLI is now going to start up, and it's going to go through the code and find these failure causing inputs. It's telling us right away that it found one test case already, but it's going to look all over the code again in order to find the shortest test case that it can give us. You notice that this takes a long time, and we're working on minimizing that. You see here that it got us the input values of minus 32,768 in order to cause the failure. In the last step, we're going to use the test case execution engine to generate a test case from the test data that we've just gotten from CLI in order to gather the evidence that there's an actual problem in the model. We've just generated the harness, and now we're executing the test cases. And one of the test cases tells us that we actually have a problem in exactly the absolute value block we were looking at earlier. And if we look at the stimuli, so the inputs to the model, we see that it uses the stimuli that were given by CLI. In the next example, we want to provoke a division overflow by using this division block down there. In the first step, we need to do the model analysis again and need to find this division block, which we just did. In the next step, we want to generate the test data, again using CLI, which we did, and it's minus 255 in this case. We generate a test case, and we see that this test case fails and tells us that the division actually overflowed. And if we look at the stimuli, we see that the stimuli minus 255 was actually used. Our last example is a threshold violation of the output TMP out. It should never be more than 199. Once again, we have to launch the model analysis and actually find the output block here. Then we'll have to go into the test data generation and give us values that are exceeding this threshold. And once we generate and execute the test cases, we see that actually the assertion fails, and the assertion is that the value cannot go above 199, and we see that the TMP out signal is 200 in the end. In the final report that we received via email, we'll see an overview of the different fault models that were tested. We see detailed results for the fault model 1, for fault model 2, and also fault model 3. For developer convenience, we have the test cases attached. That's it for our demo video. Thank you for watching.